Video, we're going to go over Chapter 1, Section 1 in the textbook and pull out some of the main ideas to make sure that we've mastered and understand what's going on in the lab as you apply the concepts. So in this section, there's exponents, order of operations, and inequalities, which is quite a bit of information to cover. This section is generally considered a review, but if you haven't had a math class recently to cover these in depth, it may take you just a little bit longer to get through this section. So exponents are a shorthand way of writing repeated multiplication. So when we're working in a problem, if I have 3 times 3 times 3 times 3, it could be difficult to not make a copy mistake as I'm going down in the problem. So exponents are kind of a solution to that because it's much easier to write 3 to the 4th a couple times in a problem and not recopy that repeated multiplication. It takes up less space. It's more clear, it's easier to read. In this exponent, if I did the multiplication out, I would get 81. When you're working with these, you can use the Web 2.0 calculator. That's the calculator I advocate for when you're working online, and you can find a link to that in the announcements. And you can type in 3 raised to the 4th power, and it will give you 81, or you could type in 3 times 3 times 3 times 3, either one. In this exponential expression, 3 is the base. So the word base can be somewhat misleading because a lot of students are looking for like a small number below something. It's not a subscript, it's a base. And 4 is my exponent, which we will use the word power interchangeably. A number raised to the first power is simply that number. So if you remember back when you learned equations, linear equations, if I had x plus 5, it was implied there's a 1 in front of the x. So it's 1x. The same is true if I have an exponent that's not written. It's implied to be 1. So if I had just the number 5, that would be 5 to the first power. So when we're dealing with exponents and combining similar terms, that is an important thing to consider. So in here, we're basically utilizing calculator knowledge. In Web 2.0 calculator, you would type in 9 squared, and that should give you 81. If I had 1/2 to the 4th power, it's very important that the 1/2 goes in parentheses in the calculator, just like you see here. And what the calculator is doing is it's doing that repeated multiplication step for you, and you should get 1/16. Now we're going to take a look at the order of operations. When an expression involves more than one operation, we sometimes use parentheses to group things together to tell us, hey, I want you to do this step first. This is incredibly important when we use calculators, and so you're really going to become an order of operations master as you learn how to appropriately use your calculator. So when I'm doing things, the parentheses or the brackets have to be done first. Parentheses or brackets. Notice I brought up brackets. That tells you, hey, 2 times 3 here might need to be done first, so I'm going to put parentheses around it, so I'm telling you to do that first. Of course, multiplication becomes before addition, but we're talking about parentheses right now. And you can see how changing the location of those parentheses changes my answer because I'm being directed to do different operations first. If the grouping symbols are present, meaning parentheses or brackets, you have to do that first. After I've done the grouping symbols, then I'm going to do exponents, and then I'm going to do multiplication or division from left to right. There's a lot of memes going around social media right now where people are saying, oh, the order of operations has changed. It has not. The rule has always been to go left to right. So that's always been the rule, left to right. Then I'm going to do my addition or subtraction, and I'm going to go from the left to the right. If there aren't any grouping symbols, then you're just going to skip to step 1. If there aren't any exponents, you're going to skip to step 2. But make sure you're going from left to right in the problem. So if I'm moving from left to right, I have no parentheses. I have no exponents, which means multiplication is the next thing to happen. I have no multiplication here. So I'm going to do my division from the left to the right. So I'm going to do 6 divided by 2. Which is 3, and then I'm recopying that 10, and I get 7. Next, I have parentheses to deal with. So what do the parentheses mean to do? It means to do 6 minus 3. Even though that comes later in the order of operations, I want to do that 6 minus 3 first. Then I'm going to do left to right multiplication. Then I'm going to do left to right, take care of that addition. These are some additional examples. I have to deal with the parentheses first. Then I'm going to do no exponents, left to right multiplication. This is where that left to right becomes important because I'm going to do 7 times 6. Then I'm going to do 3 times 9. Then I'm going to complete the subtraction. And then number D, I finally have one of those exponents to do, so I'm going to do 3 squared, which is 9. I'm recopying, and I did 5 times 2 because right after exponents comes multiplication. So that's where the 10 comes from, is a 5 times 2. I just skipped a step there. 2 plus 9 is 11. And notice how they did the addition and the subtraction in 2 separate steps. That's because addition comes before subtraction. And then I get 1. So if we're using more than one grouping symbol, this is where we often have some confusion because brackets aren't commonly used in the lower maths, but a bracket is considered a grouping symbol. So it's not just parentheses. It's not just please excuse me, dear Aunt Sally. It's a grouping symbol. The parentheses are just the most common version of that. So if you look in here, what did they do? They took care of the parentheses first. So they did 4 plus 8. That's what they're supposed to do. If there was a bracket here, you would still do 4 plus 8 first. You do all grouping symbols first. So then I get 12 minus 3, which is 9. 9 times 9 is 81. Now we have a fraction. It's important that you realize a fraction is division. However, it's kind of like you have 2 separate problems. I have a numerator, I got to simplify first. Then I have a denominator, I have to simplify before I can handle the division of the fraction. So I take care of my grouping symbols. I take care of my multiplication. I simplify the numerator and denominator, and then I divide. So this is kind of a exception to what's going on with the order of operations. When I have a fraction, the top and the bottom are a separate problem until you get all the way to the very end. So now we're going to talk about not equal to, greater than, less than, greater than or equal to, greater than or less than. So inequality symbols we use when we're trying to indicate a relationship between 2 values. So 7 is not equal to 8 would utilize this symbol. If I had this symbol, it would be considered less than. So this would be 7 is less than 8. And I know a lot of students remember that it eats the larger number, but it's also hard when I have an equation to know if it's greater than or less than if I'm trying to put it in words or I'm trying to go from a word problem. So in general, when that arrow points to the left, that's going to be a less than symbol. And this would be greater than. So it could be read as, oh, that's the wrong symbol. That should be flipped around. So that's a typo there. If I put a bar at the bottom, that would be less than or equal to. So just as a hint in the lab, if you're doing less than, you can type it with your keyboard. If you're doing less than or equal to, that's going to come from one of the functions in the equation editor in the lab. And then we have greater than or equal to. So when it says or, that could be this, or that could happen. So if it's 5 equals 5, that could technically be 5 is less than or equal to 5. That would technically work. So here are some examples of utilizing these symbols. We're just going through and saying if it's true or false. And this is just looking at the relationship. 12 is greater than 6. 28 is actually equal to 7 times 4. 21 is less than or equal to. And 1/3 is less than 1/4 would be false because the larger the fraction denominator, the smaller the number. Now this is where sometimes we have an issue with translating the equations to words when we deal with certain functions. So 9 is equal to 11 minus 2. That one's not so bad. 14 is greater than 12. Okay, that's not so bad. 2 is greater than or equal to 2. So we're just adding the symbols in for the words. So when you see something, we're going to get to our later sections about less than, we're going to start defining less than can sometimes mean subtraction versus this symbol. Any statement with a less than can be converted to a greater than if I'm changing the order of the numbers. So I could write 6 is less than 10, but it's also true that 10 is greater than 6. So what is this talking about? If I reverse the order of the numbers, the symbol reverses as well. That's all this slide means. So if I want to take 9 is less than or equal to 15 and I want to reverse it, I'm going to switch the numbers and reverse that sign, and that's still a true statement. And that is it for section 1.1.